Neural network as pattern recognition method exists for several decades, but until Google's AlphaGo defeated the best human player, it was not considered as good as other methods such as SVM or random forest in terms of generalization to unseen data. It tends to overfit training data. The cause is clear. Before training a neural network, the number of layers and the number of nodes in each layer have to be determined by users. Without understanding the meaning of a layer, nodes, and weights, these numbers cannot be determined correctly, and the trained models will usually not work well. Neural networks are taught with terms like backpropagation, gradient descent, cross-entropy, and so on. Only people with sophisticated mathematics background can relatively easily understand them and apply them. In this video, I would like to give concrete meanings without referring to those fancy terms, to layers, nodes, and weights of a deep classification neural network, with a step function as the activation function for each node. With this knowledge, you can build solid neural network models easily. Layers, nodes, and weights in different types of neural networks mean completely different things. In another video, I'm going to give concrete meanings to these terms of a deep regression neural network. For this video, you only need high school math. For the regression neural network video, you need eigen decomposition knowledge in linear algebra. Before looking at sophisticated classification models, let's start with the simplest one. I draw it here. The input is an item with two attributes, x1 and x2, and output should be the item's class, which is represented by either a positive one or a negative one. With this neural network, when w1x1 plus w2x2 plus w3 is greater than or equal to 0, going through this activation function, we got a positive one. When w1x1 plus w2x2 plus w3 is less than 0, with the activation function, we got a negative one. For these two inequalities, an important equation shows up. It is w1x1 plus w2x2 plus w3 equals 0. In x1, x2 space, this equation is a line. I draw it here. Now let's look back to the two inequalities. Without losing generality, let's assume W2 is positive. Then W1x1 plus W2x2 plus W3 greater than or equal to 0 represents all the points above and on the line, namely in this region. And the W1x1 plus W2x2 plus W3 less than 0 represents all the points below the line, namely in this region. Taking any point above the line and passing it through the network returns a positive one. And taking any point below the line, passing it through the network returns us a negative one. With this ability, we can classify certain datasets. Suppose we have two classes of data. They locate in x1, x2 space like this. We can draw a line between them. Let's assume the y-intercept of the line is -2. And assume the x-intercept is -4. We then have the function of the line, which is x1 plus 2, x2 plus 4 equals 0. Please make sure that the coefficient of y is positive. As you can see, if you know the arrangement of data points in a space, you can draw a line to separate them, and when the line is drawn, its function is determined. Namely, the weights W1, W2, and W3 are determined. If we use positive 1 to represent the class indicated by cross, and a negative 1 to represent the class indicated by circle, then the neural network for classifying this set of data is built. How about more complicated dataset like this? We notice that a single line cannot separate these two classes of data points. So let's use two lines to cut space. Let's draw the first line. And name this line N1. When I draw it, its function is determined. It is negative x1 plus x2 equals 0. Now let's start to draw the neural network. Then I draw the second line and name it N2. The function of N2 is x1 plus x2 equals 0. Let's keep drawing the neural network. For any point above line N1 and N2 in x1, x2 space, namely this region, the network returns us positive 1 and positive 1 at nodes N1 and N2. Notice that the only class of data in this region is cross. I draw a new coordinate system based on N1 and N2 like this. Then at point 1, 1, we put a cross there. For any point above line N1, but below line N2, namely this region, the network returns us positive 1 and negative 1 at node N1 and N2. This region only contains circle class data, so we draw a circle at point 1, negative 1 in N1, N2 space. With similar reasoning, we can draw cross at negative 1, 1, and draw circle at point negative 1, negative 1. Now let's draw a line in N1, N2 space and call it N3. Once the line is drawn, its function is determined. Please make sure that the coefficient of N2 is positive. and we keep building our network to the next layer. Another line is needed to separate the remaining data points based on their classes. We call it N4. And our network becomes Now let's draw N3, N4 coordinate system. For all the points above line N3 and line N4, in N1, N2 space, we get +1 and +1 at nodes N3 and N4 in the neural network, and they belong to the circle class. So we draw a circle. For all the points below line N3 and above line N4, we get -1 and +1, and they belong to the cross class. So at point -1, +1 in N3, N4 space, we draw a cross. And finally, for all points below line N3 and line N4, we get -1 and -1, and they belong to the circle class. So we draw a circle at point -1, -1. In N3, N4 space, we only need one line to separate the two classes. We call it N5. Now let's complete our network. For all points above line N5, the neural network outputs +1. So +1 stands for cross class. For all points below line N5, the network outputs -1. So -1 stands for class circle. Our network building is completed. Any new data points with the same class close enough to the training data will be classified correctly. If you walk through this process again, you will have a very clear idea of what layers, nodes, and weights mean. During the process, we are transferring spaces from the previous layer to points in the next layer. The goal of the very first layer is to divide up the original data space in a reasonable way. The rest layers simply combines the divided spaces with the same class labels. So the first layer is the most important. Overfitting the rest layers does not affect the accuracy of models at all. The burdens in creating a classification neural network are shifted to understanding data point arrangements in high-dimensional space, and figuring out how to use hyperplanes to cut the space correctly.